Hi, so we'll start in 5 minutes, like at 6:05, so a few other people can also join by that time. So we'll start at 6:05. Okay, so I guess no one else is joining. So Ashwin, we can start the session. Okay, another person has come. So hello Aditya to the meeting. So welcome guys to like the session 4 of discrete math problem solving. So I'm Lakshya Saggi, as you may know, the TA for the Tuesday sessions, Tuesday problem solving sessions. And today we'll be covering basically like the contents of the question related to contents of like assignment 5. So basically functions and what are one functions, what are on two functions and stuff like that. So some of the concepts you may already know from your like 11th high school also, because in high school a little bit of these concepts of functions are also told, but we'll try to solve some problems related to this so that the concepts can become more clearer. So I guess I should share my screen now. So I'll just let me share my screen, guys. So so basically the plan for today will be there are like 10 or 11 questions only. Basically, some of the questions are quite straightforward related to basic theory of functions, while one or two questions may seem a little bit non-trivial, and I would recommend you guys to stick till the end so you guys can appreciate the concepts related to functions. So, okay. So, can one of you guys let me know in chat or by thumbs up that whether my screen is visible or not? So, guys, Aditya, okay, it's visible. Nice. Thanks. So, I guess we'll start with the today's session. So, okay. So let's come to the first question. So the first question basically says which of the following is a true for the given function. So basically we are given a function f which has a domain of r. R is basically real numbers and the codomain is also r, and f of x equals to x square plus 2. So now we want to find out whether the what are the properties of this function. So basically, instead of going option by option, we can just like straightforward check for. Basically, the properties are basically asking in the options we can see injective, surjective, or like bijective. Bijective just means whether it is injective as well as surjective. So we'll just check for the properties. And by the way, just a reminder, guys, injective means one function. Whether and sometimes the people get confused, so maybe just make this definition clear again. And surjective is onto functions. So if a function is one, it is injective, and if it is onto it, then it is surjective. And another bijective is one as well as onto. So basically injective as well as surjective. So just keep in mind this definition or notation for the rest of the problems also. So now I guess we'll start with let's check injective, whether f is injective or not. So yeah, we may basically for injectivity for sorry guys. So for injectivity, basically we need to show that if f of x1 is f of x2, just writing out the definitions for injective and surjective. So we guys know what we need to show. X2, then this implies x1 equals x2. So one basically means if the values of the function are two different are two values x1 and x2 are equal, then x1 and x2 should also be equal. So basically a function takes a unique value at every input. This is basically injective. And for surjectivity, I guess it's straightforward. We already you guys may already know what is the range of a function. So for surjectivity, range of f. Maybe we'll cover this in the surjective part with the f is surjective. So these definitions will be basically we'll have to write down these definitions for first question only, and we'll assume these definitions for later questions as well. So just these definitions are just as a reminder, guys. So for surjectivity, range of the function f should be equal to the codomain, and codomain is basically the right side where the function is defined. So here function is from R to R. So this right side is right side of the arrow is R. So basically codomain here is R. So let's just check for, I guess, injectivity, basically one-oneness. So one-oneness basically implies that if f of x1 is f of x2, then x1 should be equals to x2. So you guys can also let me know in chat if you guys think what should be the answer here. You can also share your answers in the chat, and maybe I can pitch in on your answer as well. So, maybe you guys can work it out like with me. So I'll just start solving this. So basically we can, yeah, Aditya, it's not injective. Yeah, you're written chat. Aditya's written in chat that the function is not injective, and yes, Aditya, you are correct. So basically, we need to show the intuitive representation of injective, or let's say this is basically a formal definition. Basically, for injectivity or one-oneness, we need to show if f of x1 is f of x2, then x1 equals to x2. But intuitive uh, notion for one-oneness is basically that a function should take unique value for every input, a unique different value for every input. So basically for two different inputs, it should take two different values. This is basically injectivity. So here we can see that f of x is x square plus 2. So here we can get a feel that the function x square is something which is suppose I take plus x or minus x. At both of these values, the value of x square remains the same. So in that sense, this does not seem to be injective. So basically, we can give a counter example that f is not injective. So f is not injective, and I've just underlined this. And reason is that take x1 equals -1 and x2, basically the x1 and x2 which we want here. Basically the two inputs on which the values will, two different inputs on which the value will be same. At both of these values, basically f of x1 is equals to f of x2, as we can see by putting in x. Basically, we take two values like -1 and 1, and we can see easily that f of x is x squared plus 2. So -1 squared as well as 1 squared is 1 plus 2. So f of -1 and f of 1 both will give us 3. So f of x1 is equals to f of x2 is equals to 3. So basically the function takes the same value at two different inputs. So this is why I just write as the function takes same value for two different inputs, since it is not injective. So yeah, Aditya, you're correct that it is not injective. So similarly, checking for surjectivity. So for surjectivity, we need to show that range of f is equals to codomain. So basically, this means that you must have learned this what is codomain and uh, what is range. So in the lecture, so basically, we need to show that every element of the codomain should have a pre-image. If you guys remember the definition. So basically, just writing it out. Uh, what we basically need to show, we basically need to show that for every y in codomain, uh, there should exist chan x such that f of x is equals to y. So basically, for every value of codomain for all real numbers on this right side, there should exist x such that that real number y is equals to x squared plus 2. So this is the basic definition for code surjectivity, that every element of codomain should have a pre-image. And this just simplifies to that for every value of codomain, there should exist an x such that f of x equals y. So I guess the answer to this part is also straightforward, that we can see that uh, f is not surjective. And why is this the case? Because let's just check basically, we know that to get intuitive wheel, why is it not subjective? We know that x square can only take positive values, right? So x square plus 2 will can only take values which are greater than equals to 2. But our codomain consists of all real numbers. So the values which are less than 2 will not be able to represent them. So basically for proving that it is not surjective, we just need to show there exists one y such that f of x is there exists no x such that f of x is y. So we can take any one y. Let's just take y equals to 0. So then basically what we need is okay, sorry, x square plus 2 is 0. Then basically suppose I take the value from codomain as 0, then we need an x such that x square plus 2 is 0. Then we need a real x basically. And why do we need a real x? Because our domain is limited to real numbers. If it was limited to, like, let's say complex if it included complex numbers also, then it would have been surjective, because then any value could have been represented using complex numbers. But since our domain consists of real numbers only, so uh, real x such that x square plus 2 is 0. So here, since our domain is limited to real numbers, so here we will not be able to get any x. So this is not possible. If I'll just type this comment also. If the domain was the domain included complex numbers as well, then the function would have been surjective. So this is just a side comment. So maybe this is not part of the answer, obviously, because we just need to answer whether f is surjective or injective. So basically, we can see that f is not injective as well as f is not surjective. And since it is neither injective nor surjective, it can't be bijective either. So answer is like option A, comma D. Just underline these answers. So another thing which I would like to point out here. So here f of x in the function f, the codomain was given as whole R. So instead, for injectivity, let's just suppose I'll just mention this in the comments. Like, what if the function was given as f of x is x square plus 2 only, but the function f, in function f, the domain was R, but codomain was limited to R positive only, which is basically all real numbers uh, greater than equals to 0. So in that case, do you guys think it would have been injective? Like, let's not talk about surjective, because it won't be surjective in this case also, because in that case we can take y equals to 1. So in that case also it will not be surjective, but do you guys think it will be injective? If anyone can answer it in chat. Aditya, you say that it won't be injective. Even if, yeah, okay. Oh, okay, my bad, sorry. Aditya, you're right that it won't be injective, but suppose now I reduce it from, yeah, instead I write instead now I limit the domain to R positive, and the codomain is, let's say, R only. Codomain doesn't matter in for injectivity. So is F injective? Now is it injective? What do you guys think? So I'll just answer this. So basically, now it will be injective. And why is this the case? Yes, Aditya, you're correct. It will be injective. And why is this the case? Because we can easily prove this also. And how can we prove this? So if so basically we for injectivity we need to prove that if f of x1 is f of x2, then x1 equals to x2, right? So here let's just take x1 and x2 such that f of x1 is equals to x1 and x2. So take x1 and x2 such that f of x1 is equals to f of x2. This implies that basically uh, x1 squared plus 2 is equals to x2 squared plus 2. I'll just write it down. And from here we get that basically 2 will cancel and we'll get that uh, x1 squared is equals to x2 squared, right? And here we could have got that this implies x1 squared is equals to x2 squared implies x1 is equals to plus minus x2, right? But since we have limited the domain to r positive only, so basically if x1 was positive, then x2 would also be positive only. So basically, let's say x1 was suppose 5, whatever or anything, then x2 would also have to be plus 5 only. It can't be minus 5 since our domain is limited to r positive only. So in this case, we could have said that x1 is equals to x2 as domain is limited to r positive. So just a side note which I want to point out here. This is because basically you can't just comment on whether function is injective or surjective or anything just based on the function f of x. You also need to know what is the domain and codomain of the function. Basically, these properties of injectivity and surjectivity can change depending on what are the domain and codomains of the function. It just don't depend on the function. It also depends on these uh, from where to where is the function mapped. Okay, guys, so this was the main thing which I wanted to point out. Like in surjective as well, since the domain was limited to real numbers, the function was not surjective. But if the domain included complex numbers, then the function would have been surjective. So yeah. So if anywhere you write a function, you also need to mention from where to where is the function mapped. Otherwise, things don't make much sense. So, okay, so this was what I want to discuss. So let's come to the second question then. So second question is, so second question is basically asking us that suppose we consider the following table. This table contains name of 5 students and their heights, and we can think of this function f from the set of students to the set of integers between 160 and 70. So basically, this table can also be thought of as a function, right? A function whose domain is the set of students. So basically, domain of the function is like first element of the domain set is Rohit, second is Amit, Krishna, Athar, and Nitin. Like these are the 5 elements, and f of Rohit is equals to 168, and f of Amit is equals to 165, f of Krishna is equals to 169. So basically, a function is a basically a mapping. So the domain can be these names also. It just not be any real numbers or integers only. Like it can be these names also. Uh, so basically, uh, also, it can be thought of as a set of integers with function from set of students to set of integers between 160 and 170. So basically, here we are given that codomain of the function. So basically, domain of it we are given is this set. Domain of f is equals to set of students, and codomain we are given as integers between 160 and 170, right? So basically 160, 161, 162, and so on. So Aditya is saying that the correct answer is option D. Let's just come to that. What will be the correct answer? I don't know. I just solve it with you guys. So the codomain is integer. So basically domain of every set of students, and codomain is integers between 160 and 170. And we are given that f of Rohit is 168, f of Amit is 165, and we are given these five values. So now we need to find whether f is basically 1, 1 on 2. We need to check for these two properties basically for answering this question. So let's just see whether f is 1, 1. 1, 1 is basically injectivity. So basically we need to show for the function to be 1, 1, we need to have that every input should take a distinct value from other inputs, right? A unique value from different from all the other inputs values. So like Rohit, so we can see that Rohit takes 168, Amit takes the value 165, but Nitin is also taking the value 165. So basically there is two elements, Amit and Nitin, which both take the value 165. So this function can't be 1, 1. For this function to have been 1, 1, we can see all other values are distinct, 168, 165, 169, 170, but this 165 gets repeated again. Suppose it was Nitin had a height of 164, then the function would have been 1, 1. But here it is not 1, 1 since Amit and Nitin have the same, not 1, 1. I'll just underline this also as f of Amit is f4. So another thing to note for you guys is that like for proving whether a function is 1, 1, like let's come to the first question itself. For proving that if a function is 1, 1, we need to take this formal definition into account. We take any such x1 and x2 and show that f of x1 is equal to f of x2 implies x1 equals x2. But to show, so basically for proving a function is 1, 1 or ontoness, 1, 1ness or ontoness, we need to show we need to show that these properties hold for all possible values. But for showing that a function is not 1, 1, we just need to show an example where this property does not hold. Similarly, for ontoness, we just need to show an example where this property does not hold. Like in the previous question only, we just took, for proving that f is not injective, we just took the values -1 and 1, and we showed that for this example, it is not 1, 1. So overall, it won't be 1, 1. And similarly for ontoness also, we just took 1y and showed that this property does not hold. So it won't hold. So this function is not ontoness. So basically, just want to point out that for disproving stuff, you just need one example, and for proving stuff, you need to prove it for all possible values. Okay, so yeah. So now to show whether f is 1, 1, now to answer whether f is 1, 1, I just said that f is not 1, 1 as f of Amit is f of Nitin is 165. And this example is like enough as a proof that this function is not 1, 1. But if we had to show that it is actually 1, 1, then we would have to show that all the elements take different values. So yeah. So now to check whether f is onto. So for f to be onto, basically we need all the integers, let's say between 160 and 170. So which are basically 160, 161, 162, 163 up to 170. So we need to show that the range should be equals to the codomain. So basically every one of these values between 160 and 170 should have a pre-image if the function is onto. But as we can see that the value, like let's say the value 161, no one takes the value, no student has height equals to 161. So no one takes, the function does not take the value 161 over any of its elements of the domain. So here also we'll just say that it is not onto, and the reason which we can give is no student has a height of 161 centimeter. So only this much is sufficient to say that it is not on 2, and this much is sufficient to say that it is not on 1. So, so using these two, we can just say that f is neither 1, 1 nor on 2. So answer is option D. So yeah, third, you wrote option D if I remember correctly. Aditya wrote option D in the chat. So yeah, Aditya, you are correct. Good job. So now let's come to the third question. So questions are basically of similar flavors. Here we'll be traversing mostly these concepts of one, one, and onto-ness only, but in different ways, which you may find interesting. Some questions which lie ahead. So yeah. So let function is basically from R to R, so that f of x is x by 2 plus 7. So which of the following options is correct? So f is not a function. So this statement is definitely not correct. So let's just say option by option. So basically a definition or for a function is that it should take a value, it should take a value for every possible element of the domain, right? So basically for every real number, this x by 2 plus 7 should take a real value, which we know is true. Since x is real, x by 2 is real, so x by 2 plus 7 is also real. So as every as f of x exists for every x. Basically, uh, for every real x, a real f of x also exists. So option A is not correct, definitely. So option B is it is bijective, C is injective and surjectivity. So we'll just, I guess, check whether after establishing whether the function is whether it is a function. Now we'll check whether f is 1, 1, or let's say I'll type it injective here since the question asks in this injective form. So whether f is injective. So injectivity means that f of x1 is f of x2 should imply x1 equals to x2. So here we can see that f of x1 is equals to f of x2. This will imply that x1 by 2 plus 7 is equals to x2 by 2 plus 7. I'll just do this calculation only, guys, as we have done like this kind of calculation earlier also. So x1 by 2 plus 7 is equals to x2 by 2 plus 7. So 7 and 7 will cancel out. So basically we'll get that x1 is equals to x2. I hope it's clear to everyone. The calculation was pretty straightforward. So yes, as f of x1 is f of x2 implies x1 equals x2. So now whether f is surjective. So basically we need to find, we need to show that for every possible y, so basically for every possible y of codomain, and codomain is R here. So for every possible real number, there exists an x such that y equals to x by 2 plus 7. So for proving surjectivity, we need to say that uh, let's let's take any y take any y take any basically real number y. I'll just write down. Take any real number y, then y is equals to x by 2 plus 7 always admits a solution. So basically what I mean to say here is that, guys, so uh, so if we take any real number y, basically any element of the codomain, then there will always exist an x such that y is equal to x by 2 plus 7. And what this x will be, uh, this x will be just, we can solve this equation. It will be basically y minus 7 is equals to x by 2. So x will be like 2 times y minus 7. 2 times y minus 7. So I hope this is clear, guys, what I intend to say here. So it is surjective. And why is it surjective? We can take any real number y, basically any element of the codomain. Then for the surjectivity, there should always exist an x such that y is equals to x by 2 plus 7. Basically, y equals to f of x. And from here, we get that x equals to 2 times y minus 7 will always hold. And since y was real, this 2 times y minus 7 is real as well. So like there exists a real x such that we get this real y. So yeah, and basically note that this basically this x is real and hence belongs to the domain, right, guys? So basically, the main thing to point out here is that suppose if I change the domain here again, let's say the function was instead from like r positive to r instead of r to r, then like let's say then the function would not have, it would still have been injective, but it would not have been surjective. And why is this the case? Because if the function was from, maybe I'll just write it down uh, as a note. So uh, yeah, I'll just write down here. If the domain was instead limited to R positive, then F would not have been surjective. So this you can see easily why is this the case. So here we can again take a y. Let's say from here we see that the x which gives the perfect solution for y is 2 times y minus 7. So if y was, let's say, less than 7, suppose y was 6, then x would come out to be negative. But if we had limited our domain to positive numbers only, then we could not have gotten any x. So let's just take like it would not have been surjective as suppose uh, if the domain was limited to R positive, then F would not have been surjective. And you could have given the example case for this as y equals to 6. That at y equals to 6, x needs to be minus 2 for y equals to f of x to hold true. But x equals to minus 2 is not in the domain, so the function would not have been surjective in that case. So just pointing this out again. So basically, you can play around with functions, their domains and codomains and test their properties. So yeah, just doing that only. So, but for this question, at least for this question, like f is from R to R, f is injective as well as surjective. So f is actually bijective. So option B is correct. It's underlying the correct answer. So yeah. So I hope it's clear, guys. So any comments in chat? Okay, nothing in chat. So let's proceed to fourth question. So fourth question basically asks us, if a function is defined as f of x is equals to 2x plus 14, then the value of f inverse of 25 is. So another thing to note is that basically if f is bijective, then only is it invertible. You guys must have heard this in lectures also. And we have been taught this in high school, if I remember correctly as well, that a function a function is invertible if and only if it is bijective. So yeah, just pointing it out. So here in fourth question, it is asking if a function is defined as f of x is 2x plus 14, then the value of f inverse of 25 is. So since here the question is directly asking for the value of f inverse, so it necessarily implies that f is also bijective. And you can see that this is a linear function and this is from like R to R. So the mapping would have been from R to R, then only would this have been like bijective. So yeah, just putting it out there that if they have directly asked for f inverse, then you may assume that it is bijective. Otherwise, in functions, inverse does not even exist. So yeah. So coming to the question again, so basically we need to find f inverse of 25. So basically, what is meant by f inverse is basically we need to find an x in x such that f of x is equals to 25. So this is what is meant by an inverse, right? So suppose let's take the value of f inverse of 25 as x. So then taking f of both sides, we get f of f inverse of 25 is f of x. So we get f of x is equals to 25. And for solving this, we can say that this implies that 2x plus 14 is equals to 25. And this implies that 2x is basically 11. And so I'll just type it out as x is equals to 5.5. So this is the value of inverse of f. So yeah, I'll just underline this 5.5, or you can write it as 11 by 2 also. So yeah, Aditya, you have written 11 by 2 in chat, and that's correct. So yeah, so pretty straightforward question, I would say. So let's come to the next question then. Actually, there are some interesting questions at the end also. Like at least the last question is very interesting. So bear with me, guys, for these sort of questions. These are just for your basic concept development, and some questions are at the end which are interesting are for testing out these concepts as well. So yeah. So set C has cardinality P and a total of 5040 bijective functions. Then what is the value of P square? So basically, set C has cardinality P and a total of 5040 bijective functions. So let's say, so number of bijective functions basically means that number of, we are basically given that number of bijective functions from C to C. Say, so basically the domain is C as well as codomain is C, and we are given that the number of bijective function is 5040, and we are also given that. So basically, we need to find the value of we need to find the value of cardinality of C, right? And so from that we basically that will be P, and from that we can find P square. So basically we need to find, this is the basic theme of the question, right? So you guys must have studied it in lectures. Must have seen it in lectures, or you can derive it easily as well that uh, number of bijective functions is equals to like factorial, like of the cardinality of the set C. So basically P factorial. And how can we justify this? Basically, we have seen in lectures, like why is the number of bijective functions equals to this? So for bijective functions to hold, the function should be 1, 1 and on 2. So basically, every element of set C should map to a unique element of set C, right? So we can take any permutation of C and map it to like a fixed permutation of C. I hope you guys get it, because I'm not going to write all of that down because I think it has been covered in the lectures. So just reminding you guys that this sort of property holds. And the basic argument for this property was that we can map any permutation of C to a fixed ordering elements of C. So the argument goes around this line. Basically, we fix an ordering of elements of C on one side, and on the other side, we can basically permute all the elements of C, and we can map then any permutation. So yeah, I hope the argument for this was clear. So basically, you get that P factorial is 5040, and from that, I think it's like straightforward calculation, like what is the value of p if p factorial is 5040. So I don't remember, maybe I'll just wait. So 5 factorial I remember is 120. So 6 factorial is 720. So this would be like 7 factorial, right? 72 times 7. So yeah, this is 7 factorial. So this implies that basically p is 7. So this implies that p squared is equals to 49. So this is the answer. So yeah, okay. Now let's come to the sixth question, guys. I hope this was clear. This was nothing too fancy. Uh, Coming to seventh question. Find the domain and range of the following real valued function. So basically they are saying that we need to find the domain as well as range of of this function, and we are given that it is real valued. So if the so we are just given that this is a function, given f is a function, and codomain is equals to uh, real. Basically, the codomain of the function is real because it's said, like they have given in the question itself, that the function is real value. So we now need to find the domain as well as range. Maybe I'll just change this to like largest possible domain and range of the following, because why I've changed this like the domain and range to largest possible, because even if the domain and range set was null, then also it would have been fine. The function would have been like, if the domain as well as range sets would have been null sets, then also it would have been a function. There is no issues there. So basically, we need to find the largest possible domain and range. So at least we grasp the basic, so that we at least know like to how much extent can we add the elements or to domain and range sets. So otherwise, like there are infinite possible domain and range sets, and these sets can be just like, let's say, null sets. So that will also be a function, a mapping from null set to null set, and that's a function. So yeah. So this for this sort of thing. So I guess what makes sense is the largest possible domain and set. And largest possible here means basically we can't include any more elements in the domain as well as range. So yeah. So after this, I think the question becomes quite straightforward, guys. So basically, the domain would be uh, so for the largest possible domain, basically the only restriction is that the value of f of x should be a real number, and f of x should be real. Uh, f of x domain, for finding domain, f of x should be real, and this implies that basically square root of 3 minus x should be real. I'm not typing it out. So and square root function is real only if the value inside it is greater than equals to 0. So 3 minus x should be greater than equal to 0. And this implies that x should be like less than equals to 3. You guys can see. I guess so. So basically, for any value of x which is less than equals to 3, so x can be 3, 0, or it might like negative numbers, then this 3 minus x will take like a positive greater than equal to 0 value. So square root function will also return a real value. So yeah. So domain, we can just write it as, maybe if you want, like in this, we can just write that minus infinity to 3, and 3 is a closed bracket, because 3 values are also included, and this int represents infinity. So You can write it as x is less than equals to 3 or like minus infinity to 3, doesn't matter. It conveys the same thing. So once we have figured out the domain, then we can figure out the range as well. We just need to find out set of possible values. Range is basically set of all possible values over the domain set, right? So this will be basically so at value 3, the value of f of x would be 0, and for like value less than equals to 3, let's say like for values less than 3, as we like decrease the value from 3 to like lesser values, then this 3 minus x value will keep on increasing from like 0 to some positive values, and the square root value will also keep on increasing. So f of x will keep on increasing, and as we like decrease the value of x from 3, and we can see at minus infinity this will take like basically square root of infinity, which is also infinity only. So here we can say that uh, range is basically r positive, uh, basically all reals greater than equals to 0. I hope it's clear to you guys why this is the range, because at like exact value 3, the value of f of 3 will be exactly 0, so equality at 0. And at values below 3, this f of x value will be like greater than 0. So this will be the range set. And just if you want to denote it in set form, then this can be written as closed at 0, close brackets at 0, close, and open brackets at infinity. So yeah. So yeah. So I hope this is clear. So these are the so basically these are the largest possible domain and range, right? So maximum possible domain is this, and maximum possible range is this. So basically any subset of this domain would also have been a valid domain. Like let's say if I said the domain was minus infinity to 2, that also would have been a valid domain. And for that, the range would have been, I think, from 1 to infinity, but that would not have been the largest possible. So this largest possible word is important. Okay. I hope it's clear to you guys that why I have mentioned this, I added this largest possible thing. So yeah. Now let's come to 8th question, 7th question. So, uh, so seventh question, basically seventh question is asking us that if f and g are if f and g are functions from R to R, and f of x is 3x squared plus x minus 13, and g of x is 20 upon 3x plus 8, then FOG of 12 is. So you guys must have seen lectures that FOG basically means the composition of these numbers. So basically this means that we need to first evaluate the value of g at 12, and the value which comes out, basically the g of 12, let's say that value is something y. So we need to output the value of f of y. So this is sort of a practice question for like basically reminding you about the composition functions, right? So this also is generally covered in high school, but nonetheless, we'll just try to do it since it's not very difficult problem. So, and not too time consuming either. So first, basically, so with another thing to note is that FOG is not equal to G of F always. So sometimes it may be equal, but FOG is not equal to GOF always. So this ordering is also important. I think you guys may already know, but just pointing it out. So here it means that you need to first evaluate the one which is closer to the brackets is the one which you need to evaluate first. So you need to first evaluate G of 12 and then you need to evaluate F. If it was GOF, it was written GOF, then you first had to evaluate on F, then evaluate on the output on G. So it is possible that, so just writing this note in a different language, that it is possible that F of G is not equal to GOF. So we'll just always go in ordering. So always follow the order asked. So here the order asked is basically F of G, so we'll order G and then I guess this note is clear and self-explanatory. So first here we'll evaluate G of 12. So G of 12 will be basically 20 upon 3 into 12 plus 8. Oh my God, what is this calculation? 20 upon, let's say 36 plus 8, which is, I guess, 44. Guys, I think I need you guys to help me out here in the chat. So I think this can only be reduced to like 5 by 11. So now we need to find F of 5 by 11. So this will be like, can someone in chat also tell me what the answer to this would be? It's a straightforward calculation, right? Like I can also do it, but I just feel that you guys can also answer it faster with a calculator or something. So what I see its answer is as like, I just do this. So basically I need to evaluate 5 by 11. So it will be like 5, x square would be 25 upon 121. So it will be 3 times 25 by 121 plus 5 by 11 and minus 30. So this can be written as 55 by 121 and this is 75 by 121. So it will come out to like 130 by 121 minus 30. I think this is what you would get. And then this will come out to be, so I'll just cheat it a bit and just the answer directly. So this will come out to be like 1443 by 121. This is the final answer. I don't think it's really necessary to see how this answer came to be. Just we have followed this. Like first we calculate G of 12, then we calculated this value at F. So and we calculated F of 5 by 11. So everything else is just calculation. The only thing to note in this question is just follow the order asked. So yeah. So I'll just skip this question and go to next one. So now let's come to eighth question now. So guys, you have stopped answering in chat. So are you guys able to follow along? I just want to confirm that. Is everyone able to follow along what I'm saying? Since I don't see any message from like in chat from previous 2-3 questions. So yeah, cool. And so yeah, Aditya is listening to me at least. Nice. Saying yes. Yes, he's able to follow along. So that's good. So then let's come to eighth question, guys. So eighth question asks basically again a function and we need to check its one-oneness and on-two-ness. But here the function is a bit twisted. It's not a straightforward function as previous questions. So the function is basically note that from Z to Z. So Z means Z is the set of integers. So now the domain as well as the codomain is the set of integers now. And now the function is asking us that like it defines an f which is like x by 2 if x is even, so it halves the value of even numbers, and for odd numbers it gives out the values 0. So like basically since it is from set of integers to integers, so like basically f of 0 will be 0, f of 1 will be 0, f of 2 will be 1, f of 3 will be 0, and stuff like that. So yeah, just noting what are the value, what is the property of f of x. Now we need to find whether it is 1 1 or 2 and stuff like that. So just let's just start checking properties one by one, whether f is 1 1. So I think this is quite straightforward, as we have all like for 1 1 s we need to show that we need to have that every input should take a unique value, and we can easily see that f of x takes the value 0 if x is odd. So basically for all odd numbers it takes the value 0. So not 1 1. And why? Because for all odd numbers it takes the value 0. So uh, this is because like f of 1 will be same as f of 3 and it will be 0. But we need that for different numbers, the value should be 0. So again, one counterexample is enough to show that it is not 1 1. But if you need to show it is 1 1, then you need to prove it for all possible values. Now whether f is onto. So for ontoness, we need to find if it covers basically the range of basically f of x covers all numbers or it does not cover all numbers. So Aditya is writing the option that answer D is correct. So neither 1 1 or nor or 2. So let's just see whether it will be 1 1 or whether it will be on 2 or it will not be on 2. So basically, for all our numbers, it takes the value 0. So at least 0 is covered. Basically, the codomain is all z. So basically, the range should cover for the function to be on 2. The range should cover all z, right? So for range should cover all integers. So 0 integer is covered in the range as for all odd values. So we're left with non-zero integers, and I think basically it would be on two. I think you've written that it won't be on two, but I think it would be on two uh because intuitively why I'm seeing this is onto is because like 0 is covered using these odd values, and for every other number, for covering every other number, we can just take the x as like twice of that number. So basically what I'm saying is for every y in z, uh, take x there exists and x equals to 2y, uh, at which f of x is y. Do you see why is this the case? Because like 2y will be an integer and it would be even. So basically this x would be even. So it would take the value as x by 2, which will be like 2y by 2. And this will come out to be y itself. Uh, do you see, Aditya, what I mean by this statement? And why this would be on to then? Okay, cool. You understand what I mean. So I hope this is clear to everyone. So basically for suppose we take any y, basically for every y z, I think for any y z, there is an x equals to 2y. So at this x equals to 2y, basically uh, note that this x is even. So f of x is equals to x by 2 here, right? And at this value, so f of x will be equals to basically uh, maybe I'll just put this as a reason after this, at which, and why is this the case? Basically, there is an x at which f of x is y, and this is because as x is even, so f of x is equals to x by 2 here, which implies that putting it just x as 2y, we just put it, f of x is equals to 2y by 2, which is equals to y. So yeah. So from this we get that for every y there is an x such that f of x equals to y. So the function is onto. Yes. So you see guys, so basically this one as ontoness, these properties are much easier to check in straightforward functions like linear functions and stuff like that. But as soon as the function becomes a bit complicated, like it takes different types of values at even and odd values, then some mistakes start to creep in. Like here, I just thought that it won't be onto, but yeah, it was onto. So here are the options. So treat these types of functions with care. That's all I would say. So it is onto, but not 1, 1. So option A. Right. So I hope it's clear, guys. So now let's come to ninth question. Oh, sorry. So in ninth question here, what this is asking is it defines a relation R as R is equals to X, Y, and basically the pair X and Y both are natural numbers such that X plus Y is equals to 5. So it defines the relation R as basically the set of natural, basically pairs of natural numbers. X and Y both are natural. So this pair, this is a pair of natural numbers such that the sum of these natural numbers is 5. So natural numbers are numbers like which are greater than 0. So we can just straightforward count this relation set also. Like what are the elements of this set? So we can just see that basically x can take values like from 1, 2, 3. X can take the values 1, 2, 3, 4. And like at x equals to 1, y will be 4, x equals to 2, y will be 3. Similarly, at x equals to 4, y will be 1. And we can't take x more than that because then y will be less than equals to 0. And since y was natural, so this can't be the case. I hope you guys are following what I'm saying, since this is not too complicated. So we can just list out the relation as well. So 2 comma 3 and 3 comma 2 and 4 comma 1. So this relation consists of only these 4 elements, nothing less, nothing more. So basically, and we need to find the range. So range is basically the right side, basically of this pair, because like the domain consists of these x's and the range consists of these y's. So the range consists of like the values 4, 3, 2, and 1. So we can just say that the range is this set. Uh, Basically 4, 3, 2, 1. You can also write as 1, 2, 3, 4, 5. I just put it in this order in which it was straightforward. So yeah. So range is this set, like 4, 3, 2, 1. So you should note that like you should not define range as like from 1 to 4 and because like from 1 to 4 many real numbers can also be present. So if you write it as like the range is from like 1 to 4, then you also need to mention that we are talking only about like integers or like natural numbers and not about real numbers. So yeah, just keep in mind that's a side note and it's pretty obvious. So I won't be writing it down what I just said. So yeah, this question was pretty straightforward, I would say. So now let's come to 10th question. So 10th question is asking let A be set with cardinality n and B with cardinality m. There are a total of 3024 one-to-one function from A to B. What are the values of n and m respectively? Okay. So you guys must have seen this also in your lecture that number of one-to-one functions from A to B. So for functions to be one-to-one, basically, first of all, we need the property that the cardinality of the set B should be greater than or equal to cardinality of set A, right? Otherwise, the function can never be from one-to-one. So just typing that observation here. So since we are considering one-to-one functions, so cardinality of B should be greater than or equals to cardinality of A, which basically means that m is greater than or equals to n here, right? And also from lectures, or like we can just straightforward see also like the number of one-to-one functions. How can we count the number of one-to-one functions? So basically we need to find basically since A has cardinality n, so basically we need to find n unique elements from the set B, and then so basically we can find n unique elements from the set B in like m choose n. So MCN is basically, I'll just write that as like choose, so it becomes clearer. So in MCN ways we can just choose these n elements which we want to place in the range of like the function, and then these elements can be permuted in any way possible. So I hope you guys are following along what I'm saying, that these elements can be permuted in any ways possible, so that like suppose the first element of the set A can take like the value equals to first element of set B, as well as second element, as well as third element, or like let's say the nth element. So since we are taking n elements at a time, so uh, any valid permutation of these n elements which we have taken from set B can be mapped to like set A. So total number of permutation, so total number of one-to-one functions will be m choose n times n factorial. Uh, I hope this calculation is clear to you guys, and I think this would have also been covered in the lecture. So I'll just assume that this is clear to you guys. So and now this is given to us as 3024. So now we need to find basically like, so m choose n times n factorial is basically like mpn, basically the permutation symbol. So this is just like m times m minus 1 times m minus 2 till m minus n plus 1. So maybe I'll just write it down as well. Yeah. Okay. So this just means that just writing out the value of a formula for permutation, m times m minus 1 times m minus 2 dot 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 till m minus n plus 1 is equals to 3024. This is what the question is saying, because m to n is m factorial upon m minus n factorial. So yeah, this is what the question is saying. So maybe we'll just like, now m and n also are like, since cardinalities are integers, since cardinality of sets are integers, so note that m and n are integers here. I just also write here also note that m and n are integers. So this integrality is why we can get like sort of some unique values from for m and n. Otherwise, like if m and n were fractional, then things don't make much sense, because like how can we like first of all define total number of one functions by m choose n and stuff like that. So these are integers. So now this basically we have to solve this integral equation, that find integral m and n such that this equation holds. So we can find this by trial and error, or like just straightforward we can try to factorize 3024 in such a format basically such that we get some consecutive numbers. maybe you can factorize 3024 in multiple ways such that we get at least a bunch of consecutive numbers. So in that way, we can get maybe multiple possible values for m and n. But we'll just see whether at least one such factorization exists. I hope you guys understood what I mean. If you did not, don't worry, I'll just. So 3024 can be like factorized into, let's say, how, uh, so this can be factorized into 9. Maybe I'll just type out factorization. So this will be like basically 2 times 1512. So this again will be a 2. Then it will be 756. So I think guys, I will need your help also. So how can we like first of all write its prime factorization? So 3024 can be written as I think this much 3024. Yeah. So and then this 756 can again be written as like 2 into 378, and this can again be written as like 2 times 189, and this can be written again as like 3 times 63, and this can be written as 3 times 21, and this can be written as 3 times 7. So I've done it in front of you guys only, so it's nothing magical which I've done. I just done prime factorization by just repeatedly finding the prime factors. So so basically now what we need is basically we need to find basically m minus 1 up to m minus n plus 1 are basically consecutive integers, right? So we need to express this product as product of some consecutive integers, right? Here basically like 2, 2, 2, 2, 3, 3, 3, and 7, these are not consecutive, but we need like these consecutive integers. So maybe we can order these multiplications around in some way such that uh, we get a we get a set of consecutive integers, right? Uh, Also, so 2, 4, 16 times 9, 144. Okay, so yeah. So now to see how can we do this. So maybe there can be so you guys understand what I'm saying, that there can be maybe multiple ways of factoring this in terms of like consecutive integers. Like suppose there was some way in which we got 9 times 10 and another way in which we got like 2 times 3 times 4. Like this example doesn't hold, but in some example, like these not these exact values, but this can occur. So in that case, there can be like multiple possible values of m and n. So here also, I'm not sure if there can exist multiple possible values, but we'll try to find at least one value for m and n. So basically, I see a 7 here, so I think that there we'll need to work around this 7 only. So suppose I take these 2 times 2 times 2 and get an 8, then I get 8 and a 7. So maybe I'm making some progress here. So 8 times 7, and then the remaining elements would be like 2 times 3 times 3 times 3. So these 3 into 3 can be factorized as 9 and written as 9, and this 2 into 3 can be written as 6. So this can be written as 6 into 9. So basically this is like 6. So I got a product of consecutive integers, 6 times 7 times 8 times 9. So you see guys, like I've done no magic here, just solved it in front of you guys, like just laid out my thought process that how I approached it, like I worked on this 7 and this factorization and stuff. So from this we get that. So basically comparing this equation to like this form, we get that m is 9 and like m minus n plus 1 is 6. Just type like 9. So what this means is that this implies that m is 9, and putting 9 in this equation, in the second equation, we get that 10 minus n is 6, so n is 4. So yeah, solve this. So this is the correct answer. M is 9, n is 4, and you guys can verify the calculation as well. It's a good practice to verify your answers as well, because this involved a lot of factoring and stuff. So it might be it might get wrong. The answer might get wrong, but I think this is correct. Like 9 into 8 into 7 into 6 comes out to be 3024. So yeah, so this is the correct answer, and like this is how you approach these types of questions. So you can just see that the main properties used were these are integers, and we need to find products of consecutive integers. So there can be maybe multiple ways of like maybe like this was like 6 times 7 times 8 times 9, and there could have been like I don't know if this could have been factored in another way, but maybe suppose that it was we were able to factorize it, let's say, into 14 into 15 into 16 or something like that. So in that case, we could have also said that another possible value for m is like 16, and m minus n plus like n is 3 or stuff like that. So just note that there can be multiple answers if there are multiple possible factorizations. I don't know if this question, if 3024 has multiple possible consecutive factorizations, but in general, there can be. So yeah, at least we have got this answer, and I'm not going through the efforts of finding another answer or proving if another answer does not exist. So yeah, let's just leave this at that m is 9 and n is the 4 is the answer. Okay, so now comes an interesting question. This is like the last question of this question set which I prepared. So this is the interesting question. So what this question is asking is we need to prove that the set -1 to 1, like basically the set of real numbers from -1 to 1, has the same cardinality as the set, let's say, which maps 1 to 3 union 4 to 6. Okay, maybe okay, let's just start with the easier problem first, guys. So my bad. I just changed one question on the fly. So so suppose I had to prove that the set -1 to 1 has the same cardinality as the set 1 to 3. So what do you guys think? How can you go about this problem? Any ideas in the comments? Like, like we are in the week of discussing basically functions, right? Problems related to functions. And why does this cardinality of set? What does this cardinality of sets have to do with functions? So this has been a bit of this concept has been covered in the lectures. So like, uh, suppose f is a function from set a to b, then suppose f is a function from set a to b, and then if f is, like we have studied in lectures, if f is injective, basically 1 1, then the cardinality of a is less than equals to cardinality of b, right guys? And similarly, if f is surjective, then cardinality of a is uh, greater than equals to cardinality of b. Does this make sense, guys? This is something which you have covered in the lectures as well, at least these definitions. So basically, to show that, so basically to show that, so to show set S1, like for any set S1 has same, since these are infinite sets, you can't just exactly count the element and say that the counting of elements is same. Basically, there are infinite elements between -1 to 1 and infinite elements between 1 to 3. So you can't directly like say that the after counting the elements, the number of elements are equal. So in these types of questions, you need to go through this method of like definitions of cardinalities that basically if I can define a injective function from this set to this set and like a function which is injective as well as surjective or stuff like that, if I can define an injective function from like this -1 to 1 to 1 to 3, then this means that the cardinality of this set is less than equal to cardinality of this set. And similarly, if I define another injective function from this set to this set, then it would mean that the cardinality of this would be less than equal to cardinality of this. And if A is less than equal to B and A is greater than equal to B, then A is equals to B, right? So basically what I mean to say is that to show S1 has same cardinality as S2, we can show that basically how we approach this, how we show that two sets are equal. We show that one set is a subset of other and the other way around also. So let me just copy this. I hope I'm making sense, guys. Because if I'm not, then you guys can ask me in the chat what is not clear to you. So to show that S1 has same cardinality of S2, we can show that S1 is less than equals to S2 and S1 is greater than equal to S2. So basically, what we can show is that. So basically, we can show this by making an injective mapping. Basically, injective mapping is like one mapping from S1 to S2. This will give me that. This gives us that size of S1 is less than equals to size of S2. And another injective mapping from S2 to S1 as this gives us the same thing that it was. This was the main question which I was talking about, that it's a pretty interesting question and test the concepts a little bit. So Aditya, you're saying that we can open the set and write all its elements. So Aditya, this is an infinite set, right? So you can't just say you can open the element and write all the elements since it's an infinite set. So you have also written f of x is x plus 2. Yeah, that approach is correct. So basically that's what I was saying also. We basically can show a mapping from S1 to S2 from like this set -1 to 1 to this set 1 to 3. And we can show so another mapping from like 1 to 3 to like -1 to 1. So if I show one injective mapping from S1 to S2, then this will mean that S1 is less than equal to S2. And if I show another injective mapping from S2 to S1, this will give us that S2 is less than equal to S1. So if both of these hold, S2 is less than equal to S1 and S1 is less than equal to S2, then S1 will have to be equal to S2, right? So yeah, Aditya, actually what the argument, what the function which we have written is correct. So to show mapping from -1 to 1 to 1 to 3, to show injective mapping. Basically, we need to show a mapping which is injective. That's how we can get that the size of -1 to 1 will be less than equal to 1 to 3. So to show injective mapping from -1 to 1 to 1 to 3, we can take f of x as Aditya has written. is equals to x plus 2. So from this, we can see that every unique element from -1 to 1 will give us a unique element in this side of 1 to 3. And like -1 will give us exactly 1 and 1 will give us exactly 3. So from this, we can say that the size of -1 to 1 is less than equal to size of 1 to 3. But we need to show another thing also, Aditya, that the size of 1 to 3 is less than equal to size of 1 -1 to 1. So we need to show another injective mapping in the opposite side also to show. I hope I'm making sense, guys. If I'm not making sense, you guys should definitely ask me in the chat, because this is a very important concept in computer science. Like, how do you map in two infinite sets? Like, when can you say two infinite sets are equal, or when are they not equal? So you guys should definitely ask me if something is not clear. So now we need to show. First, we showed a mapping from -1 to 1 to 1 to 3 injective mapping. Like, this injective mapping exists, and now we need to show another injective mapping from 1 to 3 to -1 to 1. We could have also gone another way around, like to show that a is less than equal to b and a is greater than equal to b. We could have just shown that the mapping f in itself is injective as well as surjective. Because if it is surjective, then we get cardinality greater than equal to relation also. So using just this function also, we could have said that just said that this function is injective as well as surjective. So it's a bijective mapping. So cardinality of A is equal to cardinality of B. In that sense, only Aditya's function f of x equals to x plus 2 would have sufficed. But in general, it's a better approach to take these two problems independently. Like, sometimes it's more difficult to find an exact bijective mapping, but it's easier to find two injective mappings. Since bijective mapping, since for finding bijective mapping, you have to get two criteria, and that it should be one as well as on two. So I hope I'm making sense here. And Aditya has written in chat that here we can take fx is x minus 2, which is correct. So here we take fx equals to x minus 2. And here we can see that it is again an injective function, and it maps like 1 to -1 and 3 to 1. And like, and every other element is also in the range. So yeah. So here we have shown that there is an injective mapping from this to this and from this to like opposite way also. So from this, we can say that hence cardinality of the two sets is equal, right? So I hope I'm making sense. And this is the like crux of the argument. So I'll just underline this also. Right. So this was the 11 question. So I just introduced this 11 question as a preface to the actual harder question. Like, this was an easier question, like f of x was clearer, like what we f of x we can take. So now let's suppose we have to show, sorry guys, 12th question. So now we have to show that the set -1 to 1 has the same cardinality as the set, like let's say a set which consists of two disjoint intervals. And note that here this interval is closed interval, like -1 and 1 are closed. Here these intervals are open at 1 and 3 and 4 and 6. So now we need to show basically a mapping. So for proving this, we need to show like another injective mapping from this -1 to 1 to, let's just name these sets first of all. So let, for easier, let S1, oops, my bad. Let S1 is equals to this set -1 to 1. And okay. And S2 be this set 1, 3 union 4, 6. Basically all real numbers from 1 to 3 in closed interval and all from 4 to 6. So now again going through previous question, like finding an exact bijective mapping will be harder. So again taking a straightforward route, like we'll try to show injective mapping from S1 to S2. So to show injective mapping from S1 to S2. Basically, injective mappings are easier to make. I'm not taking the surjective mappings because for alternate you need to ensure that all the elements of the codomain have been taken care of or have been covered, which is, I think, which can also be done obviously, but I think it requires, at least for me personally, it requires a bit more effort. But for showing the one functions, like one functions, you can construct very easily. So that's why I prefer to go via this route of showing injective mapping from both sides and not doing the surjective thing, not including that surjective thing. So yeah, this is just my personal opinion. You guys can definitely do it the other way also, but since I am the one which is taking the pronunciation, so we'll try to do this way for now. So anyone would like to try out an injective function? So basically, we need to find an injective function now which maps like S1 to this set S2. So basically, like since this is an injective function, not a surjective function, all the values of this set should not be like, it is not necessary to include all the values of this set S2. You can like, this is why I prefer injective function in this question. Like for surjectivity, you would have to take care of all these values which are disjoint intervals. But for injectivity, you can just take like you just need an injective function and you don't need to include all the possible values of S2 in the range of that function. So I hope you get the drift of my argument. So can anyone give me a function f of x in chat? Aditya, maybe you can try. Uh, So basically, guys, I don't think it's that hard once you get this general idea, like from the previous question. So the general idea is that you need to find a function of x which takes the values from -1 to 1 and outputs the values between this in the set S2 and it is a 1 function. So you can just take linear functions and linear functions are generally always 1 1 and try to construct a linear function which lies in the range. This basically, you can just check whether it lies in the range this 1 to 3 or 4 to 6 since you don't need like uh, you basically need to show you don't need to show on trace, you just need to show that uh, the value should be part of this set S2, need not necessarily be onto. So, okay, Hital, what is the meaning of union symbol in S2? So basically 1 to 3 is like this 1 comma 3 is a set, right, of real numbers from 1 to 3, which are greater than 1 and which are less than 3. And like this 4 to 6 is the set of real numbers which are like greater than 4 and less than 6. So the union of these two sets will be just all the real numbers which lie either between 1 to 3 or lie between 4 to 6. So this is the meaning of union here, Ethan. Like this is just union of two sets basically. One set is 1 to 3, open at 1 to 3, 1 at 3, and the other is open at 4 and 6. So come on guys, try out. I don't think it's that difficult to give a function which is injective and maps. You can just try out a linear function. Like a linear function is injective, we know, and you can just try out like let's say a linear function which maps like -1 to 1 to 1 comma 3. So maybe I'll just give this out to you guys. So suppose I take the function f of x as, let's just take x by 2 plus 1. So I think everyone would agree that this is an injective function. So now let's take in what values would it lie? So this x by 2, so x lies from -1 to 1. So x by 2 will lie from -0.5 to zero point 0.5. Okay, so maybe okay, sorry. So I'll just change this to 2. And now I think it makes sense. So x by 2 will lie from -0.5 to zero point 0.5, right? And adding a 2 to that will change its value from from 1.5 to 2.5. So 1.5 to 2.5 lies in this 1 comma 3 interval. So basically all the values of x lie in the set S2. I hope it makes sense. I hope I'm making sense, guys. I just write it out also. The range of f of x is -2 or 1.5 to 2.5, which lies in the set S2. Since S2 is from 1 to 3, so 1.5 to 2.5. S2 is, even though S2 is open at 1 and 3, but 1.5 and 2.5 values are actually included, right? So if you have suppose instead taken the function f of x is x plus 2, which we had taken here also, that function would have been incorrect because at -1 the function would have taken the value plus 1. But here the plus 1 is open, so we can't have the value plus 1 in the range of the function. I hope I'm making sense to you guys. Uh, why that function f of x equals to x plus 2 would not have been valid here. But this function is valid because we have now changed the values. Okay. So uh, this is injective. I think that's straightforward to see, and like range, I've given the reason why the range lies in the set. So now let's come to the second part we have to show. Now we'll have to show that uh, we have shown that mapping is from S1 to S2. Now we'll have to show a mapping from S2 to S1. So another time we'll have to construct a function, but this time we'll have to construct a function which takes as input all these values and outputs the value in this range. So would you guys like to try this out again? Taking the hint from how we have constructed the f of x as here. Maybe I'll just give 1 minute if someone can type in chat. Otherwise, like I'll just start typing out what, like there can be multiple possible functions which follow this, but what the function which I have thought, I'll just type it out after 1 minute. It's not too difficult, guys. Okay, I think you were saying to explain again. What part do you exactly need explanation for? Can like in this, what part did you not exactly understand? So that I can explain that part correctly. Okay, maybe I'll just explain the whole spirit of the argument again. So, sorry, guys. So to show that set S1 has same cardinality as S2, we can just show that basically cardinality of S1 is less than equal to S2 and S1 is greater than equal to S2. I don't think there's too much doubt. There will be too much doubt in this statement. And basically, we have also seen in lectures that if we have a function from A to B and f is injective, then we can say that A is less than equals to B, right? So this basically means that suppose we make an injective mapping from S1 to S2. So then this will give us that size of S1 will be less than equal to size of S2. And similarly, if we make another injective mapping from S2 to S1, then this will give us that size of S2 will be less than equal to size of S1. So if we give these two mappings, even though these two mappings are different, these two mappings together will give us that size of S1 is equal to size of S2. Like in this question, we took the injective mapping, first injective mapping as x plus 2 and another as x minus 2. And from this, we were able to say that cardinality of the two sets is equal, right? So similarly here, we'll try to find a function uh, which maps like -1 to 1 to which maps this set S1 to this set S2. So for this part, I was saying, first of all, I was saying that f of x equals to x plus 2 won't work now. Why this won't work is, Aditya, because we have S1 has closed values at basically S1 contains the value -1 as well as contains the value 1. So f of x will contain, if f of x was x plus 2, then it would contain the value +1 also, and it would contain the value +3 also. But here the set S2 does not contain the value 1 and 3. Since the intervals are open at 1 and 3, it is not closed brackets. So f of x equals to x plus 2 won't work here. So we'll have to find another function. And the only property we need from that function is that the values of that function, basically the range of that function, should be a part of this set S2. Right? Should be a part of this whole set S2. So basically, if I can find a function which is part of, let's say, this 1 to 3 only, like this part only, then it will be a part of the union of this and this 4 comma 6. So maybe I just try to find out a function which maps this -1 to 1 interval to this 1 to 3 interval. So I just took a function like, let's say, x by 2 plus 2. So the range was between 1.5 and 2.5. So it lies between 1 and 3. So basically this means that I have defined an injective function which actually lies in the set S2. So basically this function, uh, so basically this is a correct function, and this says basically that the size of S1 is less than equal to size of S2. I hope it made sense, Aditya. So nonetheless, I'll just proceed to. Okay, cool. It made sense. That's nice. So I'll just proceed to write f of x again. So here now, guys, basically in this part, now I need that for every value from S2, the output of the function. Basically, I'll try to construct a linear function only, since linear functions by themselves are always injective. So at least injectivity part is taken care of. Now I just need to say that the range should lie within the set S1. It should need not be exactly equal to set S1, because exactly equal is a part of surjectivity. And we don't want surjective, we just want to show injective function. So basically, we can just see that we need to map this set S2 to. We need to find a linear function basically, which when takes every value from this element set S2 gives a value between -1 to 1, right? So suppose if I divide, these are values are quite small, right? So as set S2 would contain, all the values would lie between, let's say, 1 and 6 only. Every element contained in S2 would be between 1 and 6 only, right, guys? So suppose if I divide the value, suppose I define a function f of x is equals to x by 6. So here range, what would be the range of fx? So basically it will be like the values will be like, it will not be the exact range, but uh, we can just say that f of x always lie will always be greater than 1 by 6, since like the x is always greater than 1. So f of x will be greater than 1 by 6 and will always be less than 1 also, because like less than 6 by 6, which is 1, because like x always takes a value less than 6. So here I just write now. So f of x is as x is greater than 1 and x is also less than 6. So f of x will always be greater than f of x is, since x is like for s2, x is always greater than 1 and less than 6. So f of x is x by 6. So it will be like greater than 1 by 6 and 1 by 6 and less than 1. So basically f of x will always lie between like 1 by 6 and 1. And since 1 by 6 to every like set S1 contains values from -1 to 1. So it will contain all the values from 1 by 6 to 1 also. Right, guys? I hope I'm making sense. So all possible values of f of x will lie in the set S1. As S1 contains the values from -1 to 1, so it will also contain all the values between 1 by 6 to 1. It's like straightforward. So from this, basically, uh, we have basically shown these two mappings, one mapping from S1 to S2 and one from S2 to S1. And using these two mappings, maybe I'll just underline the functions which we have defined. These are the basic crux of the argument. And basically, we have defined. Basically, I have not proved injectivity. Injectivity is straightforward. Like these are linear functions, and in linear functions generally they are injective. So you can prove it. You can try to prove it yourself, but you can take it for granted as well. No issues there. So, and we just wanted to say after this that the output of these functions should lie in the codomain, and that's why, and that's only when this will be a valid function. So this is all which I have done in this question. So basically, we have shown one function, one injective mapping from S1 to S2 and another from S2 to S1. So this both will together imply that S1 is equals to S2. So okay. So this was a lot more trickier question than the previous question. So I hope it made sense to you guys. So we have something like 5 minutes left. So if you guys like, this was all which I had to cover from back of my mind. So if you guys have something to ask me in these 5 minutes, you can ask me. Like if you want to, if you have some doubts in this, in something which I've discussed today, then you can ask that again. Okay. So Hetal, you are saying if for some functions, domain or codomain is asked, how to identify? So I had this question, I think, Hetal. The sixth question, basically. Find the largest possible domain and range of the following real valued function. So type of function is not given. What do you mean by type of function is not given, Hetal? Can you explain a bit more? Like, do you mean to say that it is not given that it's a real valued function or something like that? Oh, so you mean that it is not given whether the function is real valued or not? So I guess Hetal, this would mostly depend on the question which, like the particular question which has been asked. But the general spirit of the questions being asked is just that very similar to this only. Suppose I had removed this thing that find the largest possible domain and range of the following function. Suppose the question was instead of this real valued function. Then you could have just straightforward argued that uh, the square root function in itself is always defined. Like we have studied this in high school as well, or you remember that the square root function is always only defined for like positive inputs only. So like I understand that under root of -1 is iota and you go into complex numbers, but you denote that using power half. Like if you say like this square root, if you use this square root function, like this root function, then this in itself always implies that the its output will always be real value. Like it can't output complex values. So basically, if you are using in itself this square root function, then it will automatically imply that you're always taking as inputs only like real positive values are the inputs of this function, and the output will always be real value. So like for this question, we could have said even if we remove this for a real valued thing, then also everything would have remained the same, because by definition itself of this root function, if you we have studied this in high school, I think, or you can search online also. By definition of this root function itself, uh, it takes only the positive values as input and outputs real values only. So square root minus one is iota, but you can always define that this root function will only denote the real valued outputs. And like suppose if I want to denote the iota terms, I can just instead write it as like 3 minus x raised to power half. So that is a different notation and a different function. And this square root, specifically this root symbol, is a different function, is a notation for a different function, which only has a codomain of R. So I hope I made some sense in answering your question, Ethan. So as for this question, like suppose if it was not given real value in that setting also, we could have found that we could have just said that square root by definition always outputs real values. So its codomain is real only, and proceeded along those lines. Otherwise, like basic methods other than that are same. Like suppose this type of thing is given, generally it should be given that the real valued function, because it's a property of this square root function specifically that it is real valued always, but it might not always be the case for all functions like sine, cos, and other functions are defined over uh, different negative complex numbers as well. So for those functions, things might get trickier. So I think a codomain should generally be given, but at least for the square root function, like again, I'm saying it depends specifically. It is like function specific question. Basically, it this thing may vary from question to question, but at least for the square root function, it is always real valued. So we can always assume its codomain to be real. So and then solve using this only, like domain, and then find domain and range using these methods which we discussed. I hope I made some sense to you, Hetal. If not, you can ask in chat. Ah, cool. I made sense. That's nice. So, any other question? Guys, we have like 1 more minute, so. Okay, I guess so. Maybe if you guys have some questions later, uh, you can just put it on discussion forum and TS can answer those questions. So for now, I guess uh, we'll conclude this meeting. So I hope you enjoyed this session, guys. So this week we basically discussed functions, and I think your assignment is due tomorrow. So all the best for your submission. So I guess we'll meet again next week. So bye bye, guys. I'll just stop the recording and then stop the meeting.